Alright, okay, so hello dears! Hello, welcome to another pre-recorded lecture in our class in clinical parasitology. And for this lecture, what we're going to talk about is your staining, okay? Staining fecal smears, ayan. So, you may be wondering, yes sir, may paiba ng background. Change venue, yes. So, I'm recording the lectures here in my house. May gani, naka-find ako way na inaani gyapon kaysa naman mag-bloom ko, no, di ba? Panalay sir, bita mag-bloom char. Pabibo ta. So, thankfully, good nakakita ko way, no? Thankfully. So, yes, nako sa balay nag-record doon because na problema gamay sa AK. So, dili ni pwedeng modto pa dito. So, but again, the show must go on. So, we need to find ways for you guys para again mo padayon atong education. Pak na pak ganun. So, muna siya two ways. So, I hope lang Japon na di mo ma-distracted, no? So again, I apologize if na yung mga sounds sa iro na nag-bark or mga chicken na nagtilaok, something. So sorry kayo. Depende na sa time na akong i-record ni. But usually gabi ako tig-record, so basta wala rin mano. But anyway, if na yung mga other sounds, I really apologize. Okay. Yeah, so this is, again, staining fecal smears. Medyo delayed taan, you know. This is a late pre-recorded lecture. Because again, supposed to be, this is the topic last week na to. But naka-upload na ko daan og handout, wala pa yung pre-recorded lecture. Okay? Because again, may problem sa AK, so muna wala ko record na yun. But here we are now. Okay, so we're going to discuss now staining fecal smears. Alright, so different methods and what does it mean when we say staining fecal smears. Alright, ayan. Medyo lower. Okay, alright, ayan. Now, before we start with staining, no, your slides, usually we use slides for staining. What we do is, before we stain is, we need to first let the slides undergo what we call fixation, okay? You'll know that in your histopathology, histotechniques, especially, and even in bacteriology, diba? Microbiology, that it's really essential, it's really vital that before staining proceeds or starts, you have to first let the slides or your smears undergo fixation. Okay, now what is fixation? Okay, so here are the purposes. Ayan. So first is, of course, we need to preserve the structures and we fix them in position. Why? Because again, during staining or during the staining procedure, your organisms that are found in your smears or in your slides, they are subjected to different chemicals of different acidity, of different pH, of different nature. So what happens is if dili siya ma-preserve, okay, if your organisms are not preserved in your slide or in your smears, the reagents used in staining can destroy your organisms. So once these organisms are destroyed, we cannot see them under the microscope na. Alright? So again, that's one of the main purpose of fixation. We need to preserve the structure. Because again, why? To prevent it from deteriorating. Okay? And unsa may reason or like, what's the consequence if ni-deteriorate ng organism? Press the buzzer, you cannot see anything under the microscope na. Alright? Which would eventually lead to misdiagnosis and not accurately diagnosing the disease of the patient. Alright? Okay, ayan. And fixes them in position. So the same reason, we don't want that the organisms will, on the smears, no, will go out, okay, or will wash out during the staining procedure. That's why we need to fix them in position. Okay, that's when the first purpose of fixation. Next is to inactivate enzymes. Now, of course, your organisms, parasites or bacteria, these are organisms that have enzymes inside of them. Now, if you don't, in a way, inactivate these enzymes or you don't render them non-functional, okay, so the enzymes are still continuing to function. So what happens is these enzymes can then kill the cells, alright, or can deteriorate the overall integrity of your organism, alright. So what happens, still the same reason, the staining procedure will be faulty. You cannot see anything under the microscope, alright. So it would not be helpful, alright. So that's why we need to inactivate these enzymes, okay, because again, they might disrupt your morphology. Alright? Okay, and lastly, toughen cell structures. Why do we need to toughen cell structures? Still the same reason. It's because we don't want that the reagents that we use, again, as I mentioned, in staining, that could be of varying concentrations, varying acidity, pH, whatever, to alter, yes, to alter the cell structure of your organisms. So that's why we need to toughen it, alright? So that's the main purpose of your fixation, okay? So again, very important, nako, I highly emphasize, please do not forget, before you start staining, you must fix it first. Dapat i-fix mo. So before ka magpa-color sa imong buhay, before ka mangita og someone that would give color to your life, make sure that you are already fixed. Wow. Karon na to siya guys actually. Ngayon ko lang yun na think na parang connection, yes. Fixed. Dapat you are fixed first, you are healed first, you love yourself first, you are very much secure, stable, you're safe with yourself, of who you are and what you can and cannot do before you dwell into a relationship. Char! Okay, diba? So same here with fixation, you need to be fixed first before you proceed with the next procedure for staining. Okay? Nagets lang? Alright, I hope nagets lang. Okay, next. Now, what are the methods of fixation? We have two types. Number one is heat fixation. Okay, when you say heat fixation, by the name itself, it uses heat. All right. So usually we use this heat fixation in bacteriology when we stain your smears to determine bacteria. And how do we achieve heat fixation? We use usually alcohol lamp. Hello, oh my gosh, hindi ko kabalo mo draw. Alcohol lamp na siya, yes. And then you have the slide here. Okay. And then you let the slide pass mga 2 to 3 times sa imuhang alcohol lamp. Okay, that's an example of heat fixation. Usually used again for bacteriology. You will know that in your bacteriology class, but I'm introducing it to you now. And I think i-introduce po ni Ma'am Teddy sa inyong intro to micro. Okay, that's the first type, heat fixation. By the name itself, heat, it uses fire or heat. Okay, it adequately preserves your overall morphology but not your internal structures. Usually for bacteriology, for bacteria, the internal structures are not necessarily routinely needed to be identified because for bacteria, we only look or we identify through staining their gram stain results. And usually, the gram stain procedure, it only affects the outer structures of bacteria. Okay, dili ang inner. Alright, so that's why heat fixation would suffice for your bacteriology, usually for bacteria. Okay, and the next type is your chemical fixation. By the name itself, chemical fixation uses chemicals, all right, reagents, all right, and a very good example of that is methanol. Okay, all right, yeah. So methanol, which is of course an alcohol, diba? CH3OH. Na-remember pa ba ang OrgChem char? Okay, so methanol. So we submerge first the slides onto a Coplin jar, di ba? Coplin jar. You all know alam nyo na yan, di ba? Coplin jar, mga glasswares. Coplin jar or a jar that contains methanol, and then we submerge the slides there, okay, for about pila ka minutes, no? How many minutes? For quite some time. Again, to fix, for fixation, okay? And your chemical fixation, it protects now the fine cellular substances and the morphology of larger and even more delicate microorganisms because it penetrates your cells, okay, overall, again, the fixation, it penetrates cells and again reacts with proteins and lipids, rendering them inactive, insoluble, and immobile. Because again, sa reason, we don't want them to continue, okay? Imagine, if you take something out of like example, bacteria in a body site, you take it in vitro, okay? So the bacteria, what happens is, of course, it's outside of its normal habitat. So what happens is, if the essential nutrients of the bacteria will not be met, like if the bacteria cannot be transferred to a culture media, example. So what happens, the next incident that could happen to the bacteria is that they will die, okay? And if they cannot be fixed, example, all right, before staining, what happens is, of course, its enzymes, proteins, lipids, whatever, they will continue to function. Okay, and again, as I mentioned, the ultimate end goal or the ultimate result is dying or mamatay na mo ang kagaw. So what happens is, ma-destroy, no, the morphology of your cells will be destroyed, okay, and so we cannot see it anymore. Staining will not be helpful anymore because again, the morphology is destroyed or damaged, okay? Now, for fixation, guys, of course, what happens is if we subject the organism to fixation, the organism will die also, right? But at the same time, it will die, but the morphology will be preserved, okay? Because we're really after morphology. Because it's through morphology that staining will happen, or the stains will penetrate the morphology, all right? And it will give color to the overall organism, which then aids us in the identification of such organisms, all right? So I hope na gets lang. All right, so fixation, it kills your organisms, okay? That's why if you have, in your internship in the future, if you have specimens, example, mga body fluids like pericardial fluid, pleural fluid that has a request for microbiology, okay, and a request for histopathology or techniques. So before you add formalin, which is an example then of chemical fixation, formalin, before you add formalin to the specimen, you must make sure that this specimen has already been cultured first before naadan og formalin. Why? What's the reason? Because again, formalin will kill your bacteria in your pleural fluid in this example. Okay, so that's the reason why, again, if you have two specimens, always go first to microbiology. If histopathology and microbiology ang request niya. Okay, why? Because again, for histopathology or histotechniques, we usually use fixative or a reagent for fixation, and that is formalin. And formalin kills your organisms, okay? So, if imo siyang unahan ng formalin before nimo siya magbuhatag sa micro, mamatay na yung mga kaagaw na nasa mong fluid, wala pa siya na culture. So, wala yung results from micro. So, kung siya mahitabo, extension. Ma-extensionan ka dears as an intern. So, and as a medtech then, very detrimental, very dangerous then. Okay, so very dapat siya i-avoid. Okay, alright. So generally the fixation kills good organisms. Alright, that's my point. Okay, alright. Ayan. Okay, so that's for fixation. Okay, grabe yung mga exercise matani. Char. Okay, alright. Alright. Next, we now go to the process of staining. Now, what do you mean by staining? Staining, by the name itself, you're artificially giving color to your organisms. May it be bacteria or parasites. But generally, similar with your culture techniques in parasitology, as I mentioned, staining is also very important, or it's part of routine diagnosis for bacteria. For parasites, staining is recommended, okay, theoretically. Staining should be included, the preparation of permanent stain smears, diba? But in routine laboratory in the Philippines, in the hospitals that I have experienced my internship in, or that I had my internship in, staining for parasites is not routinely performed, okay? So, but I think in the US and other countries, they are performing it. That's why we're discussing, okay? But generally in the Philippine setting, pinaka-routine yun ang staining for bacteriology. Okay? Because again, it's through staining. Gram stain ko lang daan sa bacteria. You get to divide the bacteria into two groups, the gram-positive and gram-negative. And from there, you can already know the different tests that you can perform to identify the unknown bacteria from your specimen. That's why staining is really important in bacteriology or in determining bacteria. But for parasites, again, you can use, it's recommended, but in the Philippine setting, based on my experience, I have not experienced it. Okay? Alright, ayan. So, again, that's for staining. What is again staining? Artificially producing or providing or giving color to your organisms. Okay? May it be bacteria or even parasites and even human tissues. You'll know that in your histotechnology. Yes, maraming stains. Maraming stains, mga pangalan ng stains sa histotechnology in your third year. So, andam na, ready na ba kayo? Okay, next sem na. Okay, alright, ayan. Now again, why do we stain? So we have different reasons. As I mentioned, it enhances the observation of the organisms, okay, because it gives colors. Aside from that, through giving colors, you then get to be able to see their different morphology, their different characteristics, their different structures, which then help you in the identification of these organisms, maybe bacteria or parasites. Okay? Number 2, differentiates one group of bacteria from another. As I mentioned, one of the routine tests yun in bacteriology, again, very fundamental yun. Yes, fundamental yun kayo siya na, established yun siya na siya one of the cornerstones yun of identifying bacteria in bacteriology is the gram staining, diba? Gram staining. I think, yes, Ma'am Teddy will explain the procedure and the principle of that. Okay, gram staining. Because again, it divides the bacteria into gram-positive and gram-negative. Okay? Alright, and through that, as I mentioned pa lang, sa duha pa lang, gram-positive, gram-negative na bacteria, once you already know that, okay, this bacteria that I isolated from this specimen is gram-positive, okay, these are the tests that I need to perform. Okay, these are, it's a gram-negative bacilli or it's a gram-negative cocci. Okay, I know these are the tests that I need to perform. to further identify the organism. Alright, so usually dito kita mag-start sa gram staining in bacteriology. Okay? Alright, and lastly, helps in the presumptive identification. Yes, as I mentioned, in bacteria, if you're much parang educated now with the different bacteria, gram stain palandaan, you can already have an idea as to what is the possible identity of this organism that you have in the specimen. Like, okay, gram-neg cocci coming from a urethral swab. Nako, press the buzzer. This could be Neisseria. Gram-positive bacilli coming from a wound of a butcher, of a fish butcher. Nako, baka pwede itong erysipelotrix. O, di ba? Kalma lang. Okay, ayan. So, you'll know that in your bacteriology. Okay? Alright, so that's the importance of staining. Okay. Alright. Ayan. Now, we go now to the composition of the stain. Di ba? As I mentioned, stain is a reagent. But it's a reagent that is also composed of different other substances pa yun. Okay? Now, this stain is again composed of first the chromogen, which is your colored compound. But it's not yet considered as a stain. And the chromogen is composed of both... okay. The chromogen is now partnered with an oxochrome, and together they now comprise the stain. But chromogen alone is not the stain. Although it is the colored compound that gives the stain its color, it's not yet the stain. Okay, it's just a part of it. Okay, but once you partner with your oxochrome, together they now make your stain. Okay, together we're high five. Charot. Okay, all right. So the oxochrome, what is the purpose? It's a chemical group that conveys ionization of the chromogen. What do you mean by ionization? It helps the chromogen attach stronger, okay, to be attached stronger to the different structures in your organisms or in tissues put in the human body, okay, for staining. So that's the purpose of your oxochrome. Okay, and the chromogen pag yun is composed or subdivided into two parts, or composed of two substances. You have the benzene, o diba? Recall benzene in yung org-chem, benzene, yes, and the chromophore, which gives the color to the benzene. Okay, so I hope na-gets lang. So chromogen, benzene, and chromophore. Okay, and the chromogen itself, pag combined sa benzene and chromophore, will now be the colored compound that gives the stain its color, or that helps the stain to give color to the organisms. Gets. But chromogen alone is not yet the stain. Okay, because you need to partner it first with the oxochrome, which is which helps in the attachment of the stain to the different structures of your organism. Okay, and together, chromogen plus oxochrome is now what comprises your stain. Okay, all right. Yeah. Okay, now we go now to different types of stains. We have first the basic stains or dyes. When we say basic, it's cationic, meaning it is positively charged. So therefore, kung positively charged siya, kinsa man iyahang ma-attract. So, it will bind to negatively charged molecules, such as mga, I think, proteins ba? Tama? Oh my gosh! Okay, or mga proteins, mga different negatively charged found in the structures of your cells, okay, or of your organisms. Okay, an example of basic dyes or stains, you have methylene blue, basic fuchsin, malachite green, yes, familiar malachite greens, ato ang catocats, catothic, crystal violet and safranine. Crystal violet, safranine, very important. These are the two main stains. Crystal violet and safranine, the main stains in your gram staining. Okay, alright, ayan. Next is, of course, if there's basic, there's an acidic. So it's an anionic, negatively charged. So therefore, it will bind to positively charged molecules. Alright. So example, mga eosin, rose bengal, and acid fuchsin. So those are the types of stains based on their charges. Okay? Alright. Actually, there are a lot of different stains pa. I did not include it na because again, it's more focusing on microbiology or bacteriology na. Alright, so I just selected those that we can use for para. Okay, alright. Ayan, kay para pa itong class, no? But gusto ko na mag-backte, charot. Okay, now there are different methods then of staining. First one is simple staining. When you say simple, it only uses one dye. Like example, malachite green in our catocats, iodine in our diantonis, diba? That's simple staining because it only uses one stain or one dye. Now, of course, in contrast, we have differential staining. So when you say differential, it uses two or more than one dye to differentiate. By the name itself, differential, to differentiate or divide the organisms into two groups. And a good example of those are gram staining and acid-fast staining. Gram staining, diba? Either gram-pos or gram-negative. And for acid-fast, either acid-fast organism or non-acid fast. Okay? Alright. So we'll discuss acid fast later and the different methods of staining for parasites. Okay, alright. And lastly, we have special staining, di ba? Sana all special. May pang staining kay special. By the name itself, special staining, you only want to stain a specific structure lang. Example, you want to stain the flagella of your bacteria. Example, flagella. Or you want to stain by the cell wall lang. Yes. Like you're not staining the whole organism. It's just staining one part of it. Okay, like a structure. Okay, not all. The rest of the staining techniques, you stain everything. Okay, all right, of the organism. Okay, all right. That's for special staining. Ayan. Okay. Now, yeah. Okay, so in the next video, I think, alright, yeah, next video na lang. In the next video, we'll now go to the main bulk of our pre-recorded lecture, which are the permanent stain smears. Because, again, this is, again, recommended theoretically by your books that should be included in the OVA and Parasite ONP examination. But in the Philippines, as I've experienced, I have not perform this, okay? But again, maybe in the future, if magawas mo, go abroad, yes, at least you know already. Alright, so in the next video, we'll talk about the permanent stain smears. So I'll see you in the next video. Okay.